In this video, we're going to look at topic 85, example 5, graph a rational function. So we're asked, what is the graph of f of x equals 4x squared minus 9 over x squared plus 2x minus 15. So the first thing we want to do with this is we're going to factor both the numerator and the denominator. You'll eventually need to find the vertical and horizontal asymptotes, but it is helpful to factor them first, and you'll see why, and I'll explain why in a moment. My numerator is the difference of two squares. 4x squared is a perfect square, 9 is a perfect square. So this would factor into the sum and difference of those squares, square roots of each of those numbers. So you'd have 2x plus 3 and 2x minus 3. Now the denominator, we're going to need to use the factor sum chart. So we need factors of negative 15. Let me rewrite that. We need factors of negative 15 that have a sum of 2. Now negative 15 tells me that one of my factors is going to be positive, one will be negative. So if they multiply to get a negative number, you need one of each. So I know 1 and 15 are not going to work for 2, so I'm going to try 3 and 5. If I make the 3 negative, negative 3 plus 5 would be a positive 2, which is what I'm looking for. If I had used 3 and negative 5, that would give me a negative 2, so the right number but the wrong sign. So we want to use negative 3, positive 5. So my factored form would be x minus 3 times x plus 5. And what we want to note here is that in each of these terms here, nothing cancels out. So the numerator and denominator are different terms or expressions, which is important because if something did cancel out, that would have eliminated one of your asymptotes, or potentially both of them. Okay, so if you can eliminate or cancel things out, your vertical asymptotes are no longer actually a vertical asymptote. But that doesn't happen here, so we don't need to worry about that. So let's actually look for the vertical asymptotes. So to find the vertical asymptotes, we want to take our denominator and set it equal to 0. Now we've already factored this, so we'll save ourselves some time and just write the factored form. And the zero product property tells me I then can take each of these pieces or expressions or terms, whatever's in parentheses, and set each one of them equal to 0. So I'd get x equals 3 and x equals negative 5. Now again, because those don't cancel out with your numerator, it doesn't set your numerator equal to 0, these are vertical asymptotes, so we can graph these in. So we have x equals 3, which would be about here, and x equals negative 5, which would be about here. Okay. So we have a left, a middle, and a right for our function when we wind up graphing this. Next, we want to look for the horizontal asymptote. And if you remember the horizontal asymptotes, we need to look at the 3 potential cases. So we need to take our expression 4x squared minus 9 over x squared plus 2x minus 15, and we need to compare our degrees. So the degrees in this case are the same, so that tells me that this is case 3. Again, you don't need to memorize the case numbers, but I'm just referencing back to our notes. So case 3 would be when the exponents, or let's say the degrees, are equal. And that means that my actual asymptote, the horizontal asymptote, is the ratio of the leading terms. So y would be equal to, and in this case my leading terms are 4 and 1. Right, there's a 1 there. So we'd have 4 over 1, which would be 4. So I have a horizontal asymptote at y equals 4. So we're going to graph that in right here. Now remember, Our graph can cross the horizontal asymptote, but it will approach it as you go towards, in this case, positive and negative infinity. All right, it is possible to pass a horizontal or cross a horizontal asymptote. You cannot cross over a vertical asymptote. All right, so we have our vertical asymptote, we have our horizontal asymptote. So we know what our graph is shaped like. So what we're going to do is we're going to come up with some points so that we can plot the rest of our graph. All right, so I'm going to go to y equals, and I'm going to type in the graph, my function. So I'm going to put parentheses. I'm going to do 4x squared minus 9, close the parentheses, then divide by x squared. Oh, I need to open parentheses there. Sorry about that. We need another set of parentheses. So let's delete this. So we want a parentheses there, and then we can type in the denominator. So x squared plus 2x minus 15. All right, notice that on the actual screen here, we're looking here, our graph goes to 24 in each direction. So that's a kind of a cue to where we should be looking at in terms of points. If I hit graph, I do see that I have 3 sections. I have this top left, this bottom middle, and that top right section. It does look like it has a horizontal asymptote at 4, which is good, but now I need to find the actual points. So we're going to hit second and then go to our table, and I'm going to go all the way down to negative 24. Do notice at 3 there's an error, which is great because that was one of our vertical asymptotes. And at negative 5 we should also have an error, which we do. Alright, so I'm going to go all the way to negative 24, and that is negative 24 would be 4.4, so I can plot that point. So that's going to be right about here. And I'm just going to pick a couple points. All of these ones are pretty similar. All right, maybe I can look at negative 15, that's at about 5, or negative 14 is about 5, so either one of those will work. So let's go with negative 14, that'll be about 5. So I'm going to have some points that are going to go right along here. And then let's see what else we can use. We want to go up to negative 5, so negative 615, that could work for us. That would be up here. So that gives us the kind of the top portion or region. Negative 8, 7.5, so that'll be somewhere in here. And then maybe I'll look at 10, or negative 10, which is at 6. So that'll be right about there. All right, we are drawing a sketch, so we're not expecting perfection here. But what I'm going to do is I'm going to connect these as best as I can, and my top left portion would look something like that. Okay, now I need points between the vertical asymptotes. So I'm going to look at negative 4, which is negative 7, or closer to negative 8. So negative 4 would be somewhere about here. Negative 3 is negative 2.25. So that'll be, as best we can get, would be probably about there. Negative 2 is at 0, or close to 0. So again, that's going to be somewhere around here. 0 is at 0.6. So really right above it. And then we should look for 1, 2, and 3. All right, 2 is at negative 1. So 2 and negative 1. So if something looks like this, this is the hardest part to graph. So this is definitely not going to be it's not going to be too accurate. But we'll draw something that kind of looks like that. Okay, let me darken that a bit for us. And use the asymptotes as guidelines, and that'll help you fill in the rest of it. All right, so we now have our bottom middle, and now we just need that top right portion. So let's go to 4. 4 is at 6. So 4, 6 would be about here. Let's find another point that we can use. Maybe 8 is at 4, or 8 comes at 3.8. Sorry. So that is going to be right below our horizontal asymptote. And now remember, you can cross a horizontal asymptote and then you'll wind up approaching it from the bottom in this case. So let's go with 12. 12 is 3.7. So we're just going to go right along this. 16 is still at 3.7. So this looks like it's going to go right along our function. And 24 will be there. So everything runs right along the horizontal asymptote just from the bottom. So we'll draw this and we'll create this top portion. And there we go. Now remember, these are sketches. They're not expected to be perfect. Just make them as accurate as you can. Going back to the factoring and the vertical and horizontal asymptotes, the horizontal asymptote is pretty easy to figure out, right? You're just looking at your three cases and you're comparing the degree of the numerator and the denominator. Your vertical asymptotes, you're going to have to factor the denominator and set the denominator equals 0. But it is important that you factor both the numerator and the denominator to see if anything had canceled out. So we had a denominator of x minus 3 and x plus 5. Let's just say in the numerator, you had an x plus 5, and this can be anything. Let's just say x minus 2. These x plus 5 terms cancel one another out. So that means that that vertical asymptote would not have applied. You would have only had this single vertical asymptote of x minus 3, or just x equals 3. So if the pieces do cancel out, your vertical asymptote will be eliminated. That does not happen in this problem, but it is a possibility in future problems. So make sure you keep that in mind. And now we're finally done with this problem.